Hi people, so this is the chapter 5 review. I know that's what it says, and then I called it a quiz, and I put that in quotation marks because it's not for marks or anything, just for practice, just to kind of check in with you. Your screen is the right color, my paper is not. This is a light blue because my printer ran out of ink. What a perfect time for that, hey? But oh well, we'll do it with what we can. So let's try through this quiz here, and if you have any questions, let me know, and we'll figure it out. No promises I don't make mistakes, because constantly make mistakes. So let's give this a shot and see how it goes. All right, number 1. Write 2 sinusoidal equations to represent the following graph. One using sine function and the other using cosine function. And this is what we're looking at. Okay, let's make some observations right off the top. One is that I can really only see one full period, like half period here. I don't get to see the full thing, maybe a little bit extra than half, but I can see half a period right there. I can see that it's kind of, like there's kind of the midline. Maybe I should put that in dotted lines because it's really not a part of what I'm talking about. And then I can see how tall it is, and I can see that it's shifted a bit from maybe like a good starting point for a sine or cosine function. So let's start with the period, because that's the worst one, I think. So period. Now period, maybe this is what I'm going to start off with. A sine b x minus c, 2 brackets around that, plus d. So that's my general function for a sinusoidal equation, and then it would be cosine if I wanted to do a cosine. B is the one I want to start off by finding, and that's related to the period, but it's not the period itself. So to find B value, I'm going to take the period and I'm going to go period equals, you know what, maybe I'll just go like this. B equals 2 pi over the period. There we go. And we know that period equals 2 pi over B, so they can kind of be switched around there. So let's try and determine from the graph here what the period is, and then we'll substitute in here, and then we'll have our first value for our equation. So I'm looking at this kind of section right here, and I'm just going to draw all over this thing. And I figure half a period takes 1, 2, 3, 4 seconds. So half a period equals 4 seconds. Well, then a full period would equal 8 seconds. Does that make sense? We could continue this and it would come back up in another 4 seconds way over here somewhere, and maybe a little bit less over here somewhere, and that would be 8 seconds from when we began. And I started at 1, and that's where I started counting, so really 1, 2, 3, 4, because we didn't start at 0, we started at 1. Alright, so here 2 pi divided by the period, which is 8, and then let's just reduce that real quick. Pi by 4. That's my B value. That's lovely. I think I'm going to put that in there right now. Pi by 4. X is just X, or you could use a theta if you'd prefer. Now let's do the other easy ones. Another easy one is the midline, which is D. So midline is how far up have we been translated? How far, usually we have the midline at 0, but now it's up at 3. This is y equals 3. So it's been translated up 3 places. So the D is plus 3. I'm just going to leave that C for a second because that's one of the more annoying ones. And then let's try A. A is the amplitude, or the vertical stretch. Let's turn on this lamp. We'll see if that makes it any better. Okay, so that's the vertical stretch. Normally, our height of our curve is 1. But it has been stretched to 2 because now it goes 2 up. So from the midline to the top, or from the midline to the bottom, that's the height. So A is 2. Let's throw a sign in there. Let's finish off this C and we'll be done. I should say y equals here as well. Okay. Now C is the shift. So how far to the right or to the left have we shifted from where a normal sine curve might be? So let's try and figure this out. I'm starting with the sine curve, and then I'll do the cos curve next. And sine curves are typically they start at the origin, they go up, they come down, and then they come back to the origin. So I'm looking at my curve here, and I want to know, where does this starting point, where would that be on here? And I think right here is where that would be. And I just want to make sure that I keep this symmetrical, so there's 1, 2, and then 1, 2 spots, just so I make sure I get it right. So that point right there is -1, 3. That's where the sine curve kind of starts. And I put that in quotation marks, even though you can't see my hands here, quotation marks. That's where it starts, because that's just how I think of it at the origin. It starts at the origin right there. So this one would start at the origin. So it's kind of like we took our curve and we shifted it 1 to the left. Now reminder, because it's inside brackets here and it's a horizontal shift, we say +1. Even though it's going to the left and you normally think -1, we do the opposite, we say +1. So that is one beautiful answer to this. Now your shift could be a bit different, couldn't it? You could also say, well, way over here, it's going to come back to, right there I think, I didn't draw that great, it's going to come back to the origin like that. And that's like another starting point for my graph. So instead of saying +1, you could have said -7. I'm just going to write that in here. Y equals 2 sine pi/4 x -7 plus 3. And then guess what? This thing repeats. So there's another answer that would be great. That would be where this starts to repeat, but over here again, like way over here. And then there's another answer if you keep going. Or if you wanted to go further this way, there's another answer, and another one, and another one. Like, there's so many different answers to this. This is the one I found first, so that's what I'm going to go with, but that's also a perfectly acceptable answer. Now, they did ask me for a cosine curve, so I better do that one. Most stuff stays the same. Actually, I should say only half of it stays the same. Instead of sine, we're going to call it a cos curve. The period stays the same, or the b value stays the same, because the period does stay the same. X, the shift will change, so I'm just going to leave that for a second. And the midline will stay the same. So now we just need to figure out what is that different shift now. So looking here, a cosine curve normally starts at the maximum of 1. It goes down, and then it comes back up to the maximum of 1 again. So my starting point is at the maximum. So here is my maximum. And that's typically where I would expect a cosine curve to start. At the top, it goes down, it comes back up. So if that's where my cosine starts, again, quotation mark, I can see the shift by it went 1 to the right. So we shifted horizontally 1 to the right. And remember again, because it's 1 to the right and it's a horizontal shift, we actually call it x -1. And again, there's more than one answer for what could go in that shift there. If you're not sure, let me know and we can talk about it. But there's definitely more than one in there, right? So that's question 1. Okay, let's try question 2. Sketch at least 2 periods of the function this. And I had to write it out because it did not want to print. And then you had a graph here as well. So I'm just going to add mine in there. Alrighty, so there's a couple different ways you can look at this. One way you can do it is think about what a regular sine graph would look like. It would look like this little picture up here, where the period is 2 pi, the maximum is at 1, the minimum is at -1. And then you can shift all of your things based on the transformations that are done here. So first transformation, it's going to be 5 times taller. Second transformation, the horizontal is going to be either squished together or it's going to be stretched out. There's going to be a horizontal shift to the left or right, and then it's going to be 3 times lower vertically. So personally, what I usually do is I kind of think about these points and I think about how they would all change in here. So I'm just going to label this a little bit. I'm going to make it go up from 2 pi, maybe from -2 pi to 2 pi. And usually what I do when I have to label it myself is I start off with what I want to go to, and then I kind of split them in half a bunch. So pi, and then I made this pi by 2, and that would be 3 pi by 2. I just put a tick for the pi by 4s because I was a little too lazy to write them in, but if you want to write them in, you go ahead. Alrighty, and you know what? I'm not really sure what to label this just yet, so I'm going to leave it for a second. We'll put some arrows on it. I'm going to leave it for a second while I think. Let's decide on some stuff. So, what I like to look at first, just so I can kind of get myself set up, is I like to look at this midpoint, this midline. So the midline is at -3, and my amplitude is 5. So if I start at -3, let's call it right there for a sec, my amplitude is going to be 5, so we're going to have to go up 5 from there and down 5 from there, which would make my minimum point -3 minus 5, which is -8. So I need to be able to get down to -8 on here. So 1, 2, 3, 4, 5, 6, 7, 8. Let's call that -1. And then my maximum point will be -3 plus 5, which would be 2. So 1, 2. Let's call that 1. So just to kind of reiterate that, the -3 is going to be the midline right there. And my amplitude is the distance above or below that midline. So we're going to go up 5, because of that 5 right there, and down 5 from there, which means my minimum point is going to be at -8, and my maximum point will be at +2. So it's good to kind of make that scale before we get started so we have an idea of what we're doing. And now let's plot some points. So I'm going to look back up this tiny little, maybe we'll just draw it down here. Where do I have space? Right here. So this is typically what a sine curve would look like, where this would be 2 pi. I didn't quite draw this right now, did I? But that would be pi. This would be pi by 2, 3 pi by 2. The top would be 1, the bottom would be -1. And of course, it's this beautiful kind of symmetrical thing that would keep going on and on and on, and would kind of keep waving down over here. So let's start off with this first point at the origin, and let's work our way through all of these different transformations. So let's start at 0, 0. First things first, it's going to be 5 times stretched vertically. So stretched vertically, 0 times 5, well, that's still 0, okay. This thing is going to be stretched horizontally, but again, it's 0, so regardless of that stretch, it's still going to be 0. It's going to be moved to the left pi by 4. So instead of being at 0, it's going to be left pi by 4, and I forgot to put little ticks in. And then it's going to be going down 3. So 1, 2, 3. There is my first point. I kind of missed. Oh, some bird just hit my window. How lovely. So that's my first point, and that corresponds to that point right there. So basically, we're taking this and we're transforming it a bunch. All right. Just pause for a second. Alrighty, let's do another point here. I like to do the last point in the revolution. I like to do the last point because then I can kind of, I don't have to do every single point, you know what I mean? So I like to do the last point. If you want to do this point next, I don't know, it's up to you. You do whatever you want. I'm going to do this one. 2 pi. So it's usually at 2 pi and 0. So right here, that's my kind of my starting point for this particular point. It's going to be vertically stretched by 5, but it's at 0 right now, so that stretch doesn't really change anything. I'm going to have a horizontal stretch, but remember that they kind of work opposite what we think they do. So vertical things are opposite. If it says 2, it's actually going to be half, by a factor of half. Remember that? So instead of 2 pi, it's going to be half of that, which is at pi. We're going to move to the right, sorry, to the left, it's positive, pi by 4, so that's pi by 4, move to the left, and down 3. So down 3 is right there. That's my first point, that's my last point, and then we can fill in some of the other ones. Okay, so let's move back to this one. Again, you do whatever order you want. This time, we're going to start at pi by 2 and 1. Okay, this time those vertical stretches are going to make a difference. So I'm currently at 1, and I'm going to be vertically stretched by 5. So instead of being at 1, I'm going to be up by 5. 2, 3, 4, 5. Okay, at 5, right up here. Did not mean to make a line. Okay, I'm going to have a horizontal stretch by a factor of 2, but really that'll feel like half, right? So a factor of half. So pi by 2 divided by 2, well, that'll be pi by 4. And let's move to the left, pi by 4, so we're going to be on the y-axis. And let's move down 3. So I was at 5, 1, 2, 3, down here. 1, 2, 3, 4, 5. Oh, and I had too many ticks. Okay, so 5, down by 3, so 1, 2, 3. Right there, I end up at 2 on the y-axis. So that's that point. Let's do this one here, that's on the x-axis. So normally I would start at pi and 0. 5 times taller, still at 0. Horizontal stretch by half. So I'm going to take pi and divide by 2, which would be right there. Go to the left, pi by 4, which is there. And go down 3. 1, 2, 3. And I'm starting to see the shape. So up, down, I'm probably going to go down. What a surprise. Let's do this bottom point right here. So 3 pi by 2, and normally we would be at -1. So 5 times vertical stretch, we're going to be at -5. 2, 3, 4, 5, right over here somewhere. We're going to divide ourselves in 2 horizontally. So this divided by 2, 3 pi divided by 4, going to be, let's see, right over in, I know where we're going to end up. We're going to end up right here, but I think we'll be right here at the -5. Go to left, pi by 4, and then we're going to go down 3. So we ended up at -5, so we're at 2, 3, 4, 5, and then down to -3, 1, 2, 3, be right here. And I missed again. So that is one period of this function. Now we could do another one this way, or we could do another one that way. I'm not going to go through all the points because I can see the pattern right here. I'm just going to plot some more points on here. Notice they're all pi by 4 apart. So to continue the pattern, I'd be going down at -pi by 2, back up to the midline at -3 pi by 2, -3 pi by 4 rather, then back up to the maximum at -pi, and down to the midpoint again. Connect my dots as curvy as I can make them. I'm not going to put arrows on it because it, oh, you know what, it said at least 2. So at least 2 means I could keep going if I wanted to. Let's put some little arrows on there. Fun, right? Basically, moral of the story is take each point and apply these transformations to it. Provide the following information. Amplitude, okay. Amplitude, 5. Period. Oh, let's do, yeah, period. Let's do period next. Let's see here. So period is related to this 2 number. Period equals 2 pi divided by b. And b in this case is 2, so just pi. So period is pi, and range. Range goes from -8 to +2. That is inclusive, so we use the square brackets. Beautiful. Let's flip. You are asked to graphically solve this equation, cos theta equals -1/2, over the interval negative pi to 2 pi. To do so, first sketch at least one period of the graph. Clearly indicate the solution you graphed. Okay. So, clearly indicate the equation you graphed, rather, not the solution. So, I have an idea of where theta is going to equal this, or where cos theta is going to equal this, because this is a beautiful value that is on my unit circle. So I already have an idea in my mind of what the answer is going to be to this, but we're going to practice graphically solving it. So first thing graphically solving it is I think that this would be an easier thing to solve if it were to look a little bit more like this, where all the numbers and all the things and all the interesting things are on one side of the equation. So let's try and put everything on one side of the equation and have this equal 0. So I'm just going to do this over to the side. Cos theta equals negative 1/2. So I'm going to multiply both sides by 2. 2 cos theta equals negative 1. And I'm going to add 1 to both sides. Whoops. Plus 1. So now I have something that I can solve, again in quotation marks. This is something I can solve where I can find answers to it. And this is also something that I can graph pretty easily, right? So what I'm going to do is I'm going to graph this, 2 cos theta plus 1. And then if I were to graph y equals 0, well, that's just right here, that x-axis. And I'm going to see where they cross each other. So clearly indicate the equation you graphed. Y equals 2 cos theta plus 1. That's what I'm going to graph. And I'm going to see where it crosses y equals 0, which is the x-axis. So compared to the last one, this should be really easy to graph because it only has one stretch and one transformation, which is like way easier. So my cos curve usually starts like this. Usually starts at the max, goes down, ends up back at the max. All right, and that usually goes over 2 pi. Alrighty, so let's start off with this maximum point. Maybe we should start off by labeling, actually. Let's start off by labeling. Oh, my interval is this. Okay, I was just wondering what I should make my interval, but it tells me, so let's make our interval negative pi to 2 pi. And then I'm going to add some half pi's on there as well. Alrighty, so let's think about where this thing is going to be vertically on here. Like, what's the range of this? Well, the midline is at 1. So if we wanted to, we could put a dotted line at 1 right there. Maybe I'll just put a little tick. Okay, there's 1. That's going to be in the middle part of our graph. So that is going to be where this line is right here. And then the amplitude is 2. So we're going to have to go up 2 from this and down 2 from this. So 1, 2, 3, and negative 1. And that should be where our graph should be within that range right there. Okay. So my starting point is usually at the max. It's usually at 0 for x and 1 for y. We're going to be stretched vertically by 2. So 1 times 2 is 2. Great. There's no difference in the period. There's no phase shift or anything like that. And it just says plus 1, so plus 1. This one's super nice because the period has not changed, right? The b value is 1. It's like there's a little 1 out in front there. 1 theta. So if period equals 2 pi divided by b, and b is just 1, well, it's just 2 pi divided by 1, which is just 2 pi. And that's super handy because then this graph is going to look really similar to this one, right? So I like to do the last point next, just personal preference. You do whatever you want. So normally we'd be at 2 pi and we'd be at 1. It's going to be 2 times taller, so instead of 1 we're going to be at 2, and then it says go up 1, so I'm going to end up at 2 pi 3 is my next point. Oh, I was wondering why that point. No, these are two separate kind of ideas right here. Just put that off in its own little box. Okay, now I like to do this one. This one's the minimum point. So it's halfway in between, which is at pi, and it's at negative 1. So pi, negative 1, that's kind of my starting point. It's going to be 2 times taller, so negative 1 times 2 is negative 2, which I don't have on my graph here, but I think it's okay because I'm going to go back up 1 right there. All right. And then I can certainly do this point right here real quick, and then this point I think I'll be able to see without doing too much work, because I know it's going to be symmetrical. So this one is at pi by 2 and 0, so pi by 2, 2 times bigger would still be 0, and then plus 1. Great. And I know this point's going to be right here because it's just symmetrical, isn't it? Alrighty, and then let's go this way just so we fill out the rest of this this domain. So I went down and up, and then I'm going to go down again right here and further down right there. So I'm going to just connect my dots real quick. Now I'm not going to put arrows on this one because it specifically says just this domain. So no arrows. Try to curve it as best I can, but didn't work great. That's all right. So let's try to actually come up with a solution now. Next, indicate the solutions to the equation graphically. Okay, great, because that's kind of what I am at here. And I want to know, where does my graph equal 0? So that's what we're working on here. Where does this thing equal 0? Alright, so we want to see, where does this thing equal 0? So where does it cross this 0 line, this x-axis? So right here would be my point. And this is honestly not the best example of, let's say, a test question, because it's not a beautiful point. It's not at pi by 2 or pi 3, but it's not at one of those. So I'm kind of using my own knowledge of what would go there. If I were to ever give you assessment, I'll give you something a little bit nicer. But it's something just past pi by 2. So just a little bit bigger than pi by 2. I happen to know that that one is 2 pi by 3, comma 0. Like that's what that point is right there. Now we could certainly check this point by saying, okay, what if I was at 2 pi by 3 right here? What would be my value on here, which would be -half, hint, hint. And then we would, make it twice as big and go up 1, and we should find ourselves at 0. Because if this is 2 pi by 3 and -half, just looking at my unit circle, that's how I know that. Twice as big would be -1, and then up 1 would be 0. So that is why we are here. The next point that where we cross the 0 here, the x-axis, would be 4 pi by 3, comma 0. And then over here, we're just past -pi by 2, and you know what, it's going to be symmetrical to this one over here. So this is -2 pi by 3, 0. So my solutions are -2 pi by 3, 2 pi by 3, and 4 pi by 3. And I apologize that these are not beautiful numbers that come up on your thing. Easiest way for me to see it, just kind of taking an educated guess, is I could tell that I'm just a little bit past pi by 2, and then I was starting to think about my unit circle a little bit. So it's not an ideal question, I'll admit. Luckily, this is just for practice. Alrighty, let's try this one. Solve the equation both algebraically and graphically over the interval 0, 8. Graphically, whatever. Okay, so this is a mess, isn't it? It's a lot of things going on in here. I'm going to start off, even if I was just doing it graphically, I'm going to start off by just cleaning it up a bit, putting everything on one side, trying to move that -4 over here. So just to clean it up, just a scotch. I hope that's a 3, because that's what I can read from my own terrible writing. So +4 to both sides, and up with +3 equals 0. Alrighty. How lovely, isn't it? Okay, so let us try and clean this up just a little bit. This is probably what I'm going to graph when I'm going to be ready to graph it, so that's good to have there just for later. But to do this algebraically, this is kind of a mess, isn't it? So I'm going to simplify this question. I'm going to make the question actually easier for myself, because I like easy questions. I'm going to simplify it for myself, and then eventually I'll have to make it a little bit harder again. So what I'm going to do is I'm going to simplify this business by saying let theta equals pi by 2 times x minus 3. And you can use anything. You can use k or a or whatever you want. I use theta typically. Don't know why. But I'm going to substitute theta for this whole business in here to make this a way easier question. Negative 3 cos theta plus 3 equals 0. And now I'm going to try and isolate cos theta so I can come up with an answer for this. Cos theta equals subtract 3 from both sides and divide by negative 3, so I'd have 1. Now, where does cos theta equal 1? Let's think about that. Here's my little graph, my unit circle there. Cos is the x part, 1 is right there. So at 0, at 2 pi, at 4 pi, I can keep going with that. I'm going to go negative 1 just to make sure. Negative 2 pi, negative 4 pi. And I don't really know how many of these I have to go through because 0, 8 is not the interval for theta. It's the interval for x. So I have to do a little bit of guessing and checking before I can really be definitive how many of these answers I'm going to need. I'm not 1,000% sure. So I'm just going to have to try a couple and see. And this would be a great final answer. I would love to stop here, except that that really isn't the question. The question is talking about x's, and here I am talking about thetas. So now that I have a bit of a kind of a sub-answer, like a part-way through answer, I have to go back and talk about x's. So I'm going to start off with this first one, theta equals 0, and I'm going to substitute 0 back in here for theta to try and figure out what x should be. Pi by 2, x minus 3. So let's try and get x by itself here. So I'm going to multiply by 2, okay, it's still 0, divide by pi, okay, still 0, equals x minus 3, plus 3 to both sides, x equals 3. That's lovely because that's between my interval. I love that answer because it's going to be one of my answers. Let's try 2 pi now. And I don't really know how many answers I'm going to have here, do I? I could probably think that through just a little bit, but I'm just going to try some. Let's try theta equals 2 pi. So here I'm going to put 2 pi in and find x. 2 pi equals pi by 2, x minus 3. Okay, a little bit more work this time. Divide both sides by 2, get pi equal pi x minus 3. Divide both sides by pi, get 1. Whoops, multiply both sides by 2. Good thing I used pencil. Okay, so I just have 4 when I divide by pi, and then add 3 to both sides, I get 7 equals x, and that's a lovely answer as well, because then again, it is still in our interval. That's great. Now I feel like it's possible I could have another answer. I think it's probably not going bigger. I don't think 4 pi is going to be an answer because, we're already at 7. I don't think we're going to be able to go bigger than that. So let's try negative 2 pi going the other direction, going like left, just to make sure that there's no other ones there. So here we're going to try theta equals negative 2 pi, pi by 2, x minus 3. So multiply both sides by 2, divide by pi on both sides, and add 3, and no, we are not in the interval. If the interval was bigger, that would be a great answer, but it's not, so it's fine, and that's it. Okay, let us graph. Okay, so those are my 2 answers, and if it just asked for algebraically, I'd be done, and that would be lovely, but it did ask me to graph as well, so let's try that. I'm going to look at this primarily. I'm just going to double check I didn't make any mistakes when I wrote this down, because that would be not ideal. And I'm going to figure out my period first, because I think that's probably helpful to know. So period equals 2 pi divided by b. Our b value is this pi by 2 business. So period equals 2 pi divided by pi by 2. And I have this beautiful fraction and a fraction, and how do we deal with that? We multiply by the reciprocal. And what's nice is that so much stuff divides to equal 1 on the denominator. And on the numerator, some stuff still divides, so I end up with 4 as my period. So it takes 4 units, or 4 radians, for this thing to start to repeat. Alrighty, so this is a cos curve. I know that it starts at the maximum, it goes down, and it goes back up to the maximum. So let's think about our range for a second so I can put some stuff on here. My midline is going to be at +3, and my amplitude is -3. So that negative, sorry, it's pretty blurry there, isn't it? That negative is going to serve to reflect over the x-axis, just like we did in the first chapter that we did together. It's going to serve to reflect it. And then the 3 part is going to be how tall it will be. So the 3 is still how tall it will be. The negative part tells us it will reflect over. So the midline will be at 3. 1, 2, 3. And then to get to the top, we'll have to go up another 3. 1, 2, 3. That'll be kind of my maximum. This will be my midline, and then 0 will be my minimum point. And they did tell me the interval 0 to 8, so I could probably put that on here as well. Okay, beautiful. So I have a domain and range, and I have a general idea about how this is going to work. Let's go point by point here and graph this. So starting at the maximum, normally I'm at 0, 1. I'm going to have a vertical reflection and stretch by -3. So I'm at 1 times -3 would be -3. So 1, 2, 3, down -3. But then I'm going to go up 3. So I'm just taking care of the vertical parts first. So I'm going to be at the minimum to start off. I'm going to have this shift, sorry, this stretch, but I'm at y = 0 right now. So I'm at x = 0 right now. So this stretch really doesn't change anything. And then it says go 3 points to the right. So 1, 2, 3. So this first maximum point actually became a minimum point right there. And I didn't mean for this to be a dot on there, it was just me thinking. So that's my first point that I add on here. Now let's go to the last one, because that's what I personally like to do, but you do whatever you want. Normally this point would be at 2 pi, but this kind of looks a little confusing because I don't see any pi's on here. So instead of thinking about the 2 pi part, I'm just going to think about the period. If this is my starting point and I repeat myself in 4, I'm going to end up right here at 7. And you'll notice I'm going to be at the exact same height, so I can just put a dot there right away because I know that that was coming. Because I've done a lot of these at this point, I know halfway in between here, I should be at the minimum, but because of that reflection, I'll actually be at the maximum, which I already figured out to be up here at 6, and I'm going to be halfway between 3 and 7, which is at 5. So 5, and the y value is 6, and there we go. Alrighty, so I'm just going to follow this pattern here. 2 points to the left, I was at the max, and then 2 points again, I was at the minimum, and then 2 points again, I'll be at the maximum, and then 1 point, well, I'll be halfway in between there, so right there. Just drawing a line now. No arrows because that's a set interval. We could certainly have looked at more points and plotted them out at how we do each one, but I can see the patterns coming now, so I don't have to be so specific about it. And really, the point here is to come up with solutions. So what I did is I graphed y equals -3 cos pi by 2 x minus 3 plus 3. And then I thought to myself, where does this equal 0? Where does y equal 0? So that's on the x-axis, right there at x equals 3, and right there at x equals 7. Oh, and I should have had one more point on here, shouldn't I? Since it said to go to 8. And those are my 2 answers, which makes exact sense because that's the exact same 2 answers I got over here. All right, if you have some questions, please let me know. Otherwise, have a good night.